Okay, in this video, we are going to do a multi-right triangle problem. And so what you'll see is that we're going to need to stack multiple right triangles and do some critical thinking to find the answer here. In a certain city, the maximum height of a radio tower on top of an office building is 30 feet. Jamie stands away from a 45-foot tall building on level ground and measures the angle of elevation to the top of the building to be 25 degrees. What is the maximum angle of elevation to the top of a legal radio tower on this building? So I like to write down what are we solving for? And we are trying to solve for what is theta. So what is theta is what we're solving for. And then I like to draw out the picture. So in a certain city, a maximum height of a radio tower on top of an office building is 30 feet. That's probably important. Jamie stands away from a 45-foot tall building and measures an angle of elevation to the top building 25 degrees. So I think I have enough information to draw this out. I'm going to start by drawing the office building. So there's our office building, and the office building is 45 feet. On top of the office building is a radio tower, and the radio tower is 30 feet. So radio tower, maybe it looks something like this. Maybe that's our radio tower with a little antenna on the top. I don't know if that's what a radio tower looks like. Just pretend. Okay. And that is 30 feet. Okay, so I've incorporated this. I've incorporated this. Jamie stands away. I don't know how far away, but Jamie's going to stand away from the ground floor of the building. There's Jamie. And measures up to the top of this building. And remember, this is not drawn to scale whatsoever. So measures up to the top of this building and says that this angle here is 25. Now this is a right triangle. Your building is hopefully perpendicular to the ground, otherwise it might fall. It's got some structural problems. And so because it's perpendicular to the ground, this is going to be a right triangle. This is going to be 25 degrees. But I thought we were solving for theta. If it gives us theta, what are we solving for? Oh, we're solving for the angle of elevation to the top of the radio tower. So we are solving for this length here, not this length, this angle here. So we are solving for this angle. Okay? Well, If I want to solve for that angle, I need two side lengths. So I would need either this side length here, or I would need this side length here. I think I could get this side length. I think I could get that side length because 45 is opposite, and this is adjacent. And so I could use tangent. So tangent of 25 degrees is 45 over A. And if I were to solve that out, well then A equals 45 divided by tangent of 25 degrees. And that I'm going to plug into my calculator. So I'll plug that into my calculator. And so I'm going to say 45 divided by tangent of 25 gives me A is 96.5 feet. So Jamie is standing 96.5 feet away from the building. Now I have two sides, because if I add the radio tower and the building together, I get 75 feet, which means now for this angle, I have its opposite and I have its adjacent. So the tangent of theta is going to be 75 divided by 96.5. To get theta alone, I'd have to do the inverse tangent of 75 over 96.5. So let's use our calculator again. And to find inverse tangent, I'm going to hit this function button, inverse tangent, and 75 divided by 96.5 gives me an angle of 37.85. So let's see what it tells us to round to. Doesn't tell us to round. So let's say we have 37.85 degrees. That is what the angle of elevation is. That is what this theta is. Does that make sense? Well, it is bigger than 25 degrees, so that's good. And it doesn't seem like it's outrageously large. So yeah, that sounds like it would be about right.